Hey everybody, Mr. Regan here, and we're going to be looking at a question about a population histogram here, making sure to come back to our slideshow and pick which of the three answers we feel is best. And we're going to be breaking down that question here. And as always, make sure you pause the video as we look to make our choice on our slideshow, and then restart the video to not only go over the answers, but the key concepts that help us figure that out. So let's go ahead and take a look. The question today is going to focus on two histograms. Both histograms deal with the number of cheetahs in two unique populations. The feature that we're looking at in both histograms is spot sizes, with the traits being small spots to large spots 1 through 10. Now, each histogram 1 and 2 has a unique set of variations and distribution of those variations in relation to the cheetahs and their spots. So the question we're looking to answer is, which population histogram has more cheetahs with the large spots? So looking at our histograms here, 1 and 2, does histogram number 1 have more cheetahs with large spots? Does histogram 2 have more cheetahs with large spots? Or does both histogram 1 and 2 have a number of cheetahs with large spots? Go ahead and make your way to your slideshow, pick your answer, and as always, pause the video and then restart it to go over the answers. All right, do you think you have the right answer? Let's go ahead and take a look. When looking at our histograms, we have to first look at the large spots. So large spots would be maybe 8, 9, and 10, maybe even 9 and 10, or maybe just 10. When we look at histogram number 1, we look at the distribution of 8, 9, and 10 versus the distribution of 8, 9, and 10 here. And when we look at that, we can see that the distribution of these variations is much higher than the variations here. You'll see for 8, 9, and 10, these three bars are larger than 8, 9, and 10 combined. 10 doesn't even have any distribution at all. So when we look at this histogram or set of histograms, we know that the number of individuals with each trait in a population can change over time. So whether we're changing in terms of the variations there, so we have 10 here, we don't have 10 here, we have 10 here, or whether it's the distribution, so 8 or 9 being kind of low here in terms of distribution and 8, 9 being kind of high here, we know that we can describe a population by the number of individuals with those traits. Along with that, we know that in our histograms, the number of traits is the trait here is representing the number of individuals with that trait. So population can be described by the traits present and by the number of individuals who have those traits. So we know that number 10, that trait here, we do not have any individuals. We have a low and kind of a little bit higher distribution here. But when we look at here, we can see that 8, 9, and 10 clearly have more than 8, 9, and 10 here. So our correct answer is the second option. So how'd you do? Hopefully you got the question right. If not, please reach out, and good luck with the rest of your questions.